Hello, my name's Sam, and today I will be doing a continuous time 48 transfer problem. The problem is already on the board, as you can tell. So we're going to go ahead and work this out and try to get it into the frequency domain. So we're going to work it out using the actual definition to change it into the frequency domain, which would be x omega equals the the integration of negative infinity to positive infinity equals x of t times e to the negative j omega t. Uh, the integration valued at the dt, so evaluated over t. So we're gonna work it out. We're gonna work it out two ways, which will be the way that I'm working it out now using the actual form that I'm writing, and then we're gonna work it out using the properties and stuff like that. That if you have like the table, you can work it out using the properties and stuff like that. So we're gonna do it both ways. So we're just gonna go ahead and work it out with the integration form. So we got our equation written out. So now all we got to do is just plug it in and then evaluate it. So for our x of t, our x of t equals e to the negative t times cosine 2t times unit step t. So the unit step of t. All right, so now we're going to set we're going to change our intervals to zero to infinity because of the unit step, because it's evaluated at just t, so it shifts our function to 0. All right, so I'm just going to go ahead and write up the next step where I'm plugging in our x of t. All right. So now our next step is we're going to go ahead and break our integration up to into two integrals because of the cosine. So, we could change the cosine into e to 2j because it's a property. So you'll have to change it into two integrals because it would become like 1/2 what you have in the first integration times e to the whatever the value in front of the t is times j, and then the minus version, and then you're going to have a positive version on the other integral, which is why you need two integrations. All right, so I'm just writing it down, and you'll see exactly what I'm talking about when I finish writing it down. So I can kind of concentrate on my writing. All right, so you see the first integration 1/2 e to the negative 5t times e to the negative 2j t. That's what the cosine turned into. It turned into that e to the negative 2j times t. So that's one part of the cosine. So I'm writing it in the other integration, which will be e to the 2j times t. All right. So the next step, we're just going to go ahead and combine all the e's, all our exponents together. So we're just going to have e times something. All right, so on one of the equation before this, one of the e to the negative 2j should be a positive. Kind of had a typo. I should have. One of them should be positive. Sorry. All right, so the next thing we're going to do is we're just going to go ahead and evaluate our integrals. We have everything we need, so we're going to go ahead and just go ahead and just take the integration of our integrals. So, for every value of e, we're just going to take what we have on the e. You're going to multiply. It's going to come on the outside because of the chain rule and all that. So it's going to come on the outside because if you actually took the derivative of anything to the e, it'd be what the exponent of e and then times whatever the e is. So we have to put 1 over our 5 plus 2j, or 5 minus 2j minus j omega is what we're going to be multiplying over. Oh, I'm so sorry. So what I'm drawing is what I'm trying to say. So we're going to have e to the negative t times 5 minus 2j minus j omega all over negative 5 minus, negative 5 minus 2j plus j omega. And it is minus because it will still, because of the negative t that it's multiplying as, that negative sign would come out as well. So it's minus because of that. And then we're just going to have the same integration on our second integral, except the 2j is going to be a positive because of everything worked out. Like I said, I'm sorry, I made a little error on one of my things. Every time. All right, so now I'm just writing up the final result after you go ahead and plug in you evaluate over our intervals, which is infinity and 0. So the infinity, because it's negative infinity, it just goes basically to 0, which would make it go to 0. So then you have minus e to the negative 0, which is 1. So since it's still minus on the outside, the minus on the bottom cancels, and that's why they're positive. So then you got 1 over 2 times 5 minus 2j plus j omega. And then for the other integration, you have 1 over the same thing, except for the 2 is positive. So that's the end value for working it out the integration way. So now what I'm doing right now is showing you how you can evaluate this exact same equation by using the tables and the properties going from the time domain straight to the frequency domain. So first of all, we're going to break it up, because on one table, it'll give you a table for e to the minus at times u of t, which in your table, it equals 1 over j omega plus that a value, which in our case is 5. So there, we'll go ahead and write that. So we got, that's exactly what it is. 5 e to the negative 5t times u of t equals 1 over j omega plus 5. So now all we need to add in is the cosine of 2t. So because we already know what we have, we're basically going to go ahead and do the somewhat of a chain rule, just like in taking a derivative or so, right? So the cosine, if you go look at it, your table, it's like 1/2 times 1 over j omega t plus j omega minus a value. So what we're going to do is, because we have that e to the minus 5t u of t, and it gave us something, all the u of t really does is shift stuff. So we're just going to go ahead and plug in our cosine stuff, which is our omega plus 2, because that is it. But what the cosine does is it makes two things. So you'll have j omega minus 2 and omega plus 2. That's what the cosine does. It has like two, one's a negative, one's a positive. And then the j is multiplied by the omega minus 2 because of our previous statement we have. So a j is going to be multiplied by a omega in the 2, but not the 5. So we still have the same answer we did earlier, but we just used a different way of getting to that answer. Thank you, and I really hope this video has helped you learn something new. All right, see you next time.